Hello everyone, welcome to the another video. So today we are going to talk about the Y2K38 problem, or we can say like year 2038 problem. So this arises from the limitation of the 32-bit time representation used in many computer systems. So this is like a time computing problem, you can say. So we will talk about that, what exactly it is and what things are going to affect and what could be the solution to fix this one. So first we'll start with like understand what exactly it is, because we are talking about the 2038. So we are in, this is like a next decade, late into the next decade, and we are talking in between this decade. So what exactly it is? So this issue will cause a problem at precisely 3:14:07 UTC time zone on January 19, 2038, when the maximum value of a signed 32-bit integer that is going to exceed, which starts from the January 1st, 1970. So that will going to be exceed. So at this point, the integer will overflow. So and whatever the seconds has been defined into the integer, those are going to exceed from the 1970 till the 2038 on January 19. So those are going to exceed at that point. So the integer will overflow and that will reset to the negative value. So that will effectively rolling back date to December 13, 1901. So in layman terms, you have to tell like after, if we are using the 32-bit time representation systems, so after the January 19, 2038, 3:14:07, after that time, or that exactly that time, the date of entirely systems will go back to 1901. So whatever the softwares or the whatever the applications are using that system date, those are going to affect at all. This is the problem of Y2K38 or year 2038 time representation with respect to the 32-bit system. So let's talk about few examples, because the even though date is in 2038, why we are talking in 2024? Because some systems, some softwares can be still affected earlier as well. So let's talk about those reasons. So first, let's talk about important point is like a future calculation with respect to these scenarios actually. So scheduling and the planning softwares which comes under this future data calculation. So software that plans or schedule events for futuristic dates, such as a booking systems, airlines, or long-term management tools, or for the particularly projects, might already be dealing with dates beyond 2038 with respect to the some of the long-term projects. Yeah. So these systems can encounter the issue if they use a 32-bit time representation. Also, let's talk about the expiration dates. Systems managing some certificates, contracts, or any other entities with long-term expiration dates can run into the problem if they extend past 2038. So that will also going to affect. Those will have a wrong calculation with respect to these dates. Then simulation and the testing. Data simulation application that simulates future scenarios like financial projections, climate models, uh, might involve the data beyond 2038, leading to incorrect results or the incorrect values. So then the software testing, like automated testing environment that validate a system behavior for the future date, then also it is going to impact if they are going to use the 32-bit representation. The third one is like embedded system. So within the embedded system, like a legacy system, many embedded systems, particularly in industry or medical devices, have a long span actually. So where built it with a 32-bit processor, the system may not be updated frequently, can fail when the future dates are involved. And then data exchange is also one of the reason, because the system that exchange the date and time data with other systems that might encounter issues if one system uses the 32-bit representation and another uses the 64-bit. Then inconsistent handling of the data can lead to errors and the data corruptions as well. So then again, like a some of the like a libraries and the dependencies. So some like a software dependencies, if for example, if any application relies on the third party libraries or other component that uses the 32-bit time representation, it can inherit the Y2K38 problem even if the main application uses the 64-bit time. So these are the reasons, are the few early examples with respect to the Y2K38 problem. So now we will talk about the few of the like scenarios how we have to make those corrections, or maybe what things can be taken care as part of this rectification. So let's talk about those into the basic level. So what is the solution? The primary solution to the Y2K38 problem involves transitioning from the 32-bit time representation to the 64-bit time representations in computer systems and the softwares as well. So there are multiple steps involved to do as this transformation, or maybe this transition from 32-bit to the 64-bit. There are other considerations also needs to be taken care in stepwise, like upgrade to 64-bit system. So for example, operating system, ensure that operating system in use support the 64-bit time representations. Then update the software. So within the application code, review and update application to use the data types capable of holding the 64-bit integers for the time representation. So for example, integer to long. Then database schemas, modify the database schemas to store the timestamp in format that supports 64-bit integers such as a big integer in SQL database. Then testing and validation. Then raising awareness and the training uh, amongst the developers, system administrator, and the stakeholders about the Y2K38 problem. And at the end, it's like a monitoring and the maintenance of the system. So these are the steps to perform or take a preventive actions for this Y2K38 problem. Yeah, thank you.